Let's start solving trigonometric equations. Let's start by solving the basic equation sine of theta equal to 1/2. And let's restrict our thetas to between negative pi over 2 and pi over 2 inclusive. So a sine value of 1/2, that is a special sine value related to the point 3/2, or radical 3 over 2, comma 1/2, right? And the angle that lands us at this point in this restriction is pi over 6. Right? So theta is equal to pi over 6, and that is the solution to this trigonometric equation. Okay? Let's look at another one. Suppose we want to solve sine of theta equal to 4/5. 4 over 5 is not a y-coordinate for any of the special points on the unit circle. Theta is not going to be a multiple of pi over 6 or pi over 4, but I can still express this angle exactly for this given restriction by simply using the arc sine of 4/5. Right? Because arc sine gives us the angle whose sine is 4/5, and more particularly, it's going to give us the angle from negative pi over 2 to pi over 2, whose sine is 4/5. So this right here is the exact representation of the angle whose sine is 4/5. We could use a calculator to come up with a decimal approximation. But let's work some more basic equations, but change the restrictions on theta. So what if the sine of theta is root 3 over 2, and now our theta is greater than or equal to 0, but strictly less than 2 pi. So theta can be at most one trip around the circle. So let's see here. Sine value of radical 3 over 2. That's going to occur at the point 1/2 radical 3 over 2 and negative 1/2 radical 3 over 2. So the angles between 0 and 2 pi that get me a sine value of radical 3 over 2 is going to be pi over 3 and 2 pi over 3. So with this restriction, this trigonometric equation has two solutions. Theta equal to pi over 3 and theta equal to 2 pi over 3. So what would be different if we eliminated the restriction? Right? Well, certainly pi over 3 is still a solution, but it isn't going to be enough to cover all the possible rotations that land at this point. Right? Because I could do pi over 3 and add 2 pi, add another 2 pi, or I could subtract multiples of 2 pi, and I'll still have angles whose sine value is radical 3 over 2. So the way to express that it concisely is to say theta is pi over 3 plus 2 pi k, where k is any integer. Okay. And what this expression does, this 2 pi k accomplishes, is it accounts for all the multiples of 2 pi that we can add or subtract to the rotation pi over 3. Okay. And of course we need to do the same thing for 2 pi over 3. Right. Because those will also be solutions to this equation.